I want to skip example 6 and 7 for the time being. We can come back to those at another time. But right now, I want you to come down to substitution in a definite integral. Definite integrals, just a reminder, are the ones that have the numbers. We don't need a plus c for those. So I want you to even write yourself this note. There's no plus c when we have a definite integral. So this one is a classic substitution because you can see a function and its derivative inside of this particular integrand. I've got tangent of x, and the derivative of tangent of x is secant squared x. So here we see u is tangent of x, and du is secant squared x dx. Notice I just moved the dx over already. I don't have any manipulation to do here. It's just a straight integration. Now, there are two ways we can solve this problem from here. The first one, we rewrite this problem, u du, and these values are x values. So x equals 0 to x equals pi thirds. So my option here is I can just leave this as an indefinite integral, evaluate the integral, and then substitute back in. The other option is I can create a new definite integral, and that's what we're going to do here. Instead of putting 0 to pi thirds, that was for x's. This is a function of u. I now can plug these values in. X equals 0 would go in for u. Tangent of 0 is 0, so that new bottom value would be u equals 0. And then we have to do pi thirds. So when I do tangent of pi thirds, tangent, remember, is sine over cosine. So we get square root of 3 over 1 for this one. So we would get u equals square root of 3. So now I integrate u squared over 2, and we evaluate from 0 to square root of 3. So when I plug in square root of 3, square root of 3 squared is 3 divided by 2, minus 0 divided by 2, and our answer is 3/2. Now, I want to show you, I'm going to go back to this step. I want to show you that this works with these values as well. I could have just not put values here and said, all right, the antiderivative here is u squared over 2. Now u, I could now just plug my u back in, which means I get tangent of x squared over 2, and I just use the original points, evaluated from 0 to pi thirds. So now I would plug in my values. Plug in pi thirds. Tangent of pi thirds is square root of 3. Square root of 3 squared is 3. And then I'd plug in 0. Tangent of 0 is 0, so 0 over 2 is 0. Either way, I get the same answer. It does not matter which way you do this problem.